Patrick Cook here. Hey, thanks for stopping in. I appreciate it. Thanks for staying with our Mandelbulb tutorial series along the lines of an animation project that I'm pursuing that we are utilizing as an opportunity or as an excuse to talk about the various features and functionality of the Mandelbulb3D software. The last session I was tweaking the formulas to try to get us to our model graphic, in which case I'm going to keep moving forward for a full animation, which will all be covered here in this tutorial series. Now, so I'm going to continue in experimenting and tweaking in my formulas until I think that I've gotten something that I can run with in terms of further developing the animation. All right, so let's see what we got. So, all right, so I did push that to main. I did save it. Let's come back over here. Let's walk out. There we go. Let's walk out. I'm going to rotate. Okay, rotate. Let's see what we got here. I'm going to slide up. I'm just trying to kind of dial in a, I'm going to look up. Going to rotate it just a little bit. There we go. I'm going to push that over to main. See what it looks like. All right, interesting. Okay. All right. You see here that I've got a sense of depth. I've got a sense of depth. I've got some curvature going on. In photography, these kind of visual attributes can be very, very interesting. You notice here that I've got, from a vantage point, from the camera, the viewer standpoint, and the artist standpoint as well, I've got a curve going on, you see, and this curve is taking me out of, it's visually directing me out of the frame. If you can kind of think of it as a path, yeah, out. You see, and in photography, it's very interesting because what you want to try to do with photography is give the viewer an experience. Part of the experience is a sense of movement, a sense of depth, of course, an association, something that they can understand, that would help them kind of make sense of the image. With fractal graphics, you can do that by controlling the geometry of the image. And so in this case here, I've got a nice curve going on, which gives a real sense of perspective, but yet it's not just a straight, boring perspective. It kind of bends. It bends and it takes the viewer out of the image. And as a matter of fact, it's interesting because this graphic is bending sort of in the wrong direction. All right, you know, Americans tend to read left to right. Well, this graphic here is tending, it's suggesting a movement of right to left. So it's kind of opposing something that, say, an American would be comfortable with. So this is kind of setting up a little bit of tension. And also, we're moving into darkness. All right, so that sets up a little bit more tension. And the viewer doesn't really know where it goes. It just kind of goes off to nothingness. That's another level of tension. All right. Plus, there's some interesting visual what would you call them, artifacts that are going down in here. You know, it's interesting because this graphic here, which is nowhere close to what I would be satisfied with, is actually has some elements of an interesting artistic a point where the lines and the curves and the detail and the mystery and kind of the enclosure. This is an uncomfortable image. Doesn't have to be that way. I can manipulate things. I can make this as comfortable as I want. But maybe I don't want to. Maybe I want to put the viewer in a confined space. Maybe I want to have them be uncomfortable with exiting the frame in the wrong direction, in an uncomfortable direction. Maybe that's what I want. That's all part about being an artist. And when you're a fractal artist, you have software tools like the Mandelbulb3D that would give you a digital canvas that you control and manipulate with math. And the cool thing about it is you don't need to understand the math. I'll give you an example. Let's go back over to here. Here's formula number one. Formula number one. Here's Amazing Box. Now they're giving us 3 properties that we can control of this formula. So what's the formula? If we look at info, that's the formula. The Amazing Box, aka Manbox formula, invented by Tglad at fractalforms.com. The formula for one iteration looks like this. That's the formula. I don't need to understand that formula. I don't. I mean, I can. I could take the time to study it, and it makes a lot of sense. But fractal geometry is mathematically based. That's the nature of the beast. What we can do here is we can use this mathematical manipulation of not just one formula, but we can mix the formulas, all right? And we can mix them in different ways, like that, so that we can get some very interesting graphics out of it, which we probably could do something with, all right? So that's what I was doing. I was in the process of fooling around, seeing if I can find an interesting point of view. All right, I'm just going to rotate that. Okay. Let's get this, rotate that a little bit more. All right, let's push that to main, see what we got here. Interesting. Now, what if I was to take and walk that in? You see the ceiling? See the ceiling up there? I'm going to walk that. I'm going to walk in, and I want to get under the ceiling. I want to get under the ceiling here. Now I need to slide down. I'm going to slide down. I'm going to walk forward a little bit further and rotate just a little bit, kind of straighten it up. You see my guides here? My guides are actually helping me kind of understand the level. And of course, the center point here, the coordinates are showing me the exact center of the graphic, of the frame. All right, so let's view the main, calculate. Now, it's very busy. It's very distracting. The sense of depth is a little lost. The ceiling here doesn't really contribute to the scene. I've actually sort of went backward, but that's okay, because working with the Mandelbulb3D, or just about any fractal generator software, is a process of discovery. So I have discovered something that I don't really like. That's cool. I'll just move on. And we'll move on in the next session. I'll see you there.